Hi, everybody. Welcome to our third live session on the numerical analysis course in NPTEL. So today uh, we will take some questions. Okay. Uh, are you able to hear me? Okay. So Parthi madam has told that we are audible. So today I will wait for the questions from the students. Yeah, students, please ask some questions if you have. Yeah, so Kiran Paul is asking which type of questions come in Python related. Uh, from the examination point of view, we may not have much from the Python coding. Um, we may simply give a few lines and ask you what is the output of this line, or this is a part of the program for which method. This kind of questions may be asked. Otherwise, we will not ask you to write any Python code or something. Okay. So mostly all the questions are objective questions. We don't have subjective questions. So we may give some 4 or 5 lines small Python code, which may be a complete code or a part of a Python code, and then we'll ask what is basically the Python code all about. Say, for instance, I may take a part of Python code of the Newton-Raphson method and ask you what this Python code actually does. So, you can see that the formula written there is corresponding to Newton-Raphson. So you can, from there you can see that it may be from Newton-Raphson method, and then you can tick the multiple choice question. So like that it can. So Kiran, are you familiar with Python before this course, or you are learning in this course only? I see. Okay. So are you comfortable with Python? I mean, now after attending this course. Okay. So what about the theory part, like the methods and analysis of the numerical methods? Uh, are you able to follow from our lectures and assignments? Okay, that's good. See, main aim of this course is to learn numerical methods, how to develop numerical methods, and how to do analysis of them. Python is a very small portion, although it's interesting and important in numerical analysis. But in this course, the main objective is to uh, learn the method uh, and the analysis of the methods. What is that? Kiran says assignment 9 questions. Question number. Eight.
Eight.
Huh?
Question number 8. Maybe here some
8 is the problem. Oh, I see. So this is now presently running, or it's submitted, huh? Let me see what is I don't know whether I got it here. Um, Only 8 I have. I don't have this. Can you just recall what is that problem? Assignment 9, question number 8. Because I only got up to assignment 8. I thought assignment 8 only is submitted. 9 is going on, I thought. Oh, I see. I did not bring that assignment. Kiran, can you just copy and paste that? Or that you may not be able to do, right? Remember what is it from? Can you connect to the portal and see what is the question? Okay. See, this is Cubix plane problem. This is, I think you have, yeah, A, B, C, and then you have spline with ABC, and then.
Yeah, means the equations were given, the cubic spline equation, and that had coefficients of x square, x, and constant as BCD.
Okay, okay. See, you have this unknown parameters B, C, and D. You have to find the values of B, C, and D. Now, if you go to this plane, you have certain properties for spline interpolation, right? Say, for instance, let me try to see if I can open that file. Yeah. Uh, how to share this? Now. So I hope you are able to see the slide now, right? The viewers are seeing the slide now. See, if you go to the definition of spline, you can see that there are several conditions. For instance, spline should be a continuous function on the entire interval. So in that question, you have two intervals. In one interval, you have an expression, and the other interval, you have another expression, right? So at x equal to 0, you can see that D has to be same, which is already there. And from the data, you can see that what should be the value of this plane at x equal to 0. It should be 0.25, right? So that will tell you what is D. Okay, so that will tell you what is D. And then S dash should also be continuous, you see. Therefore, if you differentiate S from the first interval and also from the second interval, that gives you C. Again at 0, it should be continuous, right? Yeah, that's happening, but how will you find that C?
So by other points, you can get the equation S of minus 1 and S of 1.
Okay. S of minus 1. Okay. So S of minus 1 and S of 1. If you see, you will get the equation which involves B and C, and that you have to equate. I mean, you have to solve that system to get B and C. D is coming right directly by putting x equal to 0, and B and C are obtained by putting the other values. So basically, you are seeing the interpolation condition and trying to see that the three interpolation conditions will give you three unknowns. So it's yeah. So in that way, it's you can get B and C, and then from there you can right. From there you can add them and get that window which yeah. So yeah, that's nice. Uh, Good. Yeah, I hope you understood that. Please ask another question.
Yeah.
Kiran, again, there's a question. Is this notes sufficient for exam preparation? Yes, mostly we will ask from the notes. So if you have understood the theory from the notes, you have solved all the assignment problems by yourself. If you are not able to solve, at least you understood the solution once the solutions are released. Mostly 90% of the problems are doable in the exam. Only 10% may be testing your understanding, but that if you read the notes and understand the theory, that should also be possible for you to solve. Yeah, so PDE, so you love PDE, I think, that's very nice. Is Simpson's rule the best compared to other methods we saw in the course when we are using in a composite way? Please explain. So nice question. Is Simpson's rule the best? If you ask, yes, among the Newton codes formulas, I think with nodes fixed, if you see, what we have studied are rectangle rule, trapezoidal rule, and Simpson's rule. Among these three, Simpson is better in the sense that it has the highest precision, right? Nevertheless, we have seen in a tutorial session that, sometimes accidentally or coincidentally, we don't know, even trapezoidal rule can give exact result, in which case Simpsons may not give. Therefore, you cannot have a very concrete answer that for everything Simpsons is the best or everything something is the best. You cannot say that. But from the precision point of view, Simpson's method has the degree of precision 3, whereas trapezoidal, I think it has 1 or 2. You have to check that. I will not tell. So therefore, in that sense, maybe Simpson is better than rectangle and trapezoidal. From a very from the way it is derived from that point of view. But performance wise, there are functions for which trapezoidal give exact result, whereas Simpson still has errors. Okay, so that's very difficult to say. Often Gaussian quadrature rules give better results than Simpson, trapezoidal, and all. Again, you cannot generalize it to everything. In many situations that happens. Okay. See, that is why the degree of precision measure is better to just have a rough idea of which method is better. Okay, you cannot but say that in all the integrations, Simpson only gives better result than trapezoidal or rectangle. That you cannot say. Yeah. Yeah, you also asked one thing that in the composite way you are asking, right? Yeah, so that is a little meaningful, perhaps. In the composite way, generally, I mean, again, you cannot make a theorem like this, but generally if you see Simpson's method, when you go with composite, it converges little faster than trapezoidal and rectangle. So that is true. Okay, so Simpson's is a little faster in convergence when compared to the other things. Okay. But that is a good question, whether we can prove this or not. I never tried. You can try to see uh, the convergence in the composite sense, whether Simpson gives a better, faster convergence than trapezoidal and rectangle. I have not thought about it, but you can check this. It's a good question, actually. One can think of looking for the order of convergence. Then Simpson gives maybe better order of convergence. We have to check that. Uh, See, application of ODE and PDE is very difficult here because we don't have much time. Mm, so, yeah, maybe in the next course we can try to see. Uh, because if you get into applications, it's really vast. Okay, the aim of this course is to learn how to develop a method and how to do analysis. Okay, therefore, uh, really from the application point of view, we are not dealing this with this methods, right? So maybe in the next course we can think of bringing some applications also. Yeah. Yeah, we are in the last week we are discussing Tangikota method and then multi-step methods. And then we are also discussing why we need to go for implicit methods and compared to explicit methods. All that are coming in the final week. But I think we cannot touch upon PDEs. I don't have much time to do PDEs. Let us see. If there is some time, we can see, but I don't see any scope for that. ODs, fully it is on ODs, that is for sure. So there are many people, so you can ask some questions, we can discuss. So now it is 10th week is going on.
Yes.
So 9 is over. Okay, so it means interpolation is over. Now it is
It is.
integration is going. Okay, so that's good. So you can ask a lot of interesting questions from interpolation. It's not an easy topic. Uh, so if you have any doubts, you can ask. Yeah, so quadrature rule, week 10 has quadrature rules. You're right. Uh, so we have finished interpolation. So how comfortable you are in interpolation concepts now? Okay, that's good. So you also seems to be understanding a lot. You are asking good questions. So that's what you asked about the composite way is a very good question. You can try to prove the convergence of the Simpson's method and try to see what is the order of convergence there. And you can compare it with trapezoidal. I think the Simpsons should be nice from the composite point of view. So you can ask some questions from the interpolation also. Yeah, so yes, plane interpolation is very lengthy calculations. If you want to go construct this Cubix plane, it's very lengthy. Therefore, we will not ask you to construct a plane interpolation. That will take like half an hour to construct. But the small technical questions we will ask, like what we gave in the assignment, that's not very difficult. It's very easy. Like that, we will just give some parameters and you can just use few properties of this plane to eliminate those parameters. So such questions are only possible in a objective exams. Okay, so certainly we will not ask you to compute the full plane. Yeah. Okay, very nice. Yeah, so see, this is numerical analysis, so uh, we cannot avoid giving calculations, but uh, well, yeah, so some conceptual questions with MCQ will also be asked, so therefore it's not going to be that much calculation, but still you cannot avoid completely calculations. Okay, so sometimes calculation questions become easy, but only problem is that you may tend to make mistakes in the calculation. That is the problem. Conceptually, they are more easy, right? Yeah. Oh, so interpolation, there is one by Burden and Fairs. We have given in the introduction, uh, uh, in the first video, very first lecture. Burden and Fairs is there. That's a very good book. You get a lot of problems to solve also from that book. Uh, yeah, so formula sheet, if we give, then the question level should be little more high, right? Uh, so we will not be giving formula sheets. Uh, that's the problem. See, if you give formula sheets, then the difficulty level will go up. And that we don't know whether everybody can make out. See, formulas are not very difficult for you to remember. Okay. See, for instance, nonlinear equations, they are so geometrically intuitive that you don't need to really mug up those formulas. Say, for instance, if you see regular falsy method formula or secant method formula, they may look very scary, right? So they have big expression, but it is simply the point of intersection of the line joining the 2 points, right? The secant line joining 2 points with the x-axis. So if you just remember this geometry, even if you forget, you can just write the equation of the line joining 2 points and then see where it intersects the x-axis, you will get that formula. Right? So that is why we are giving all the methods with their geometric intuitions. Say, for instance, Simpson's method. you don't need to remember that formula. Say you can also come to the exam hall if some question on Simpson method is there. You know that how to get your quadratic interpolation, right? So you just write the quadratic interpolation, just integrate it, you will get it, right? So therefore, you don't need to really remember these formulas. Once you know how they are obtained, what is the idea behind deriving them, even if you just do, it doesn't come in your mind, you can immediately just derive it there itself and use that formula, right? So our aim in the course is to introduce the subject as a creator. Okay, so after doing this, you should be able to think of making your own methods. Okay, so therefore, I will also appreciate if you don't remember or mug up the formula, just come there and see, okay, Simpson's method means it comes like this. I have to have the quadratic interpolation. I have to integrate it and get the formula. Only thing I have to remember that it should be coming from the quadratic interpolating polynomial, and the nodes are a plus b by 2 and b. Once you know this, you get the formula immediately, right? So like that, you should have the idea behind these methods. You should try to remember that, but not the formula as such. Okay, so there's nothing wrong in giving these formulas, but then what happens is the question, the difficulty level goes up. Okay, that we don't know whether everybody can face it, right? Okay. Well, 8 people are there, huh? So they can answer. So please ask questions. There are many people now online. You can ask questions. You can also ask questions from previous weeks. It's not that you have to ask only from the recent weeks. You can also ask from any week. Next live session time, I will tell as soon as possible. We will try to keep on Tuesdays during 4 to 5. I hope that is okay for you all. Unless it is not so convenient, it can change, but otherwise, we will always fix this Tuesday at 4 o'clock. I will talk to Bharti madam and fix the date as quick as possible. Okay. Any questions from the recently joined? people? Any more questions? So if there is no question, we will wind up. So we'll just wait for 2 minutes. If there is no question, probably we will end the session. It's also coming to an end. So Bharti madam, can we end the session? Yeah, see there is okay, so thank you very much, everybody. We will meet in the next live session. See you. Bye.